Hello and welcome to today's class. So today we'll be dealing on sigma and pi bonds. So what are sigma and pi bonds? Sigma bonds are the first type of covalent bonds formed by overlap of atomic orbitals head to head. They are found in single, double and triple bonds, while pi bonds are the second and third types of covalent bonds formed by overlap of p orbitals side to side. They only exist in double and triple bonds. Now this is sigma and this is pi. Okay, whenever you see something like this, a circle, it is an s orbital. And whenever you see something like this, just like an infinity sign, it is a p orbital. So when an s orbital covalently bonds with an s orbital head to head, it forms or gives us a sigma bond. And when an s orbital covalently bonds with a p orbital head to head, it gives us a sigma bond. But then when a p orbital covalently bonds with a p orbital side to side, it gives us a pi bond. Now take note of this. Whenever you see a single bond in a compound, there is a sigma bond in it and there is no pi bond in it. Whenever you see a single bond in any compound, there is a sigma bond in it and there is no pi bond in it. And also, whenever you see a double bond in a compound, there is one sigma bond in it and there is one pi bond in it. Finally, whenever you see a triple bond in a compound, there is one sigma bond in it and there are two pi bonds in it. So let's take an example for better understanding. Example 1. So assuming we have something like this. Now, so we have here 3 carbon atoms in this compound and 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen atoms in this compound. So how do we find the number of pi and sigma bonds in this compound? Now, how many bonds do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have here 10 bonds and there are single bonds. This is a bond. This is a single bond. This is a double bond. And this is a triple bond. So we only have 10 single bonds in this compound. And one single bond gives us one sigma bond. Or in one single bond, there is one sigma bond in it and there is no pi bond in it. So since we have 10 single bonds, that means we have 10 sigma bond and 0 pi bond. So there are 10 sigma bonds in this compound and there are no pi bonds in this compound. So let's take another example. Example 2. So assuming we have something like this. Now let's find the number of sigma and pi bonds in this compound. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 single bonds in this compound. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 single bonds in this compound. And in one single bond, there is one sigma bond and there is no pi bond. So since we have 10 single bonds, that means we have 10 sigma bond and 0 pi bond. Now, if you look at this compound, we only have one double bond here. And in one double bond, there is one sigma bond and one pi bond. Let me come again. In one double bond, there is one sigma bond and one pi bond. So we have here one double bond, which gives us one sigma bond and one pi bond. So in total, we have 11 sigma bond and one pi bond. Okay, let's take another example. Example 3. So assuming we have something like this. Now let's find the number of pi bonds and sigma bonds in this compound. Now, let's count the number of single bonds. We have 1, 2, 3, 4, 5 single bonds. We have 5 single bonds. And in one single bond, there is one sigma bond and no pi bond. So 5 single bonds gives us 5 sigma bond and 0 pi bond. Okay, let's count the number of double bonds in this compound. We only have one double bond in this compound. And in one double bond, there is one sigma bond and one pi bond. So we have one sigma bond and one pi bond. Okay, let's count the number of triple bond in this compound. We only have one triple bond in this compound. Okay, in one triple bond, there is only one sigma bond and 2 pi bonds. In one triple bond, there is one sigma bond and 2 pi bonds. So we have one sigma bond and 2 pi bonds. So in total, we have 7 sigma bonds and 3 pi bonds. So this is how we know or determine the number of pi bonds and sigma bonds in a compound.